Hi, I'm Kian. In this video, I'm going to show you how to find the eigenvalue and eigenvector given a matrix. So you have this matrix A, 1, 10, negative 3, 12. We want to find the eigenvalues. So basically, to find the eigenvalues, the matrix has to basically have this equality, that the matrix A times the vector x, which is the eigenvector, is equal to lambda, which is the corresponding eigenvalue, times the vector x. So now we can see that we can actually simplify this a bit by turning this into basically subtracting lambda times vector x from both sides and then factoring out, so we can get x times the matrix A. However, we can't really write matrix A minus lambda because matrix A is a matrix and lambda is a constant. We can't subtract a constant from a matrix. But what we can do basically is to be able to kind of do this operation without changing the answer is to multiply lambda by the identity matrix I. Identity matrix is kind of multiplied by 1 in kind of real values. It doesn't change anything. And identity matrix in 2 by 2 is actually the matrix. I'm just going to write it here, 1, 0, 0, 1. So if we carry out the algebra, we can see that this becomes the vector x, and then we have, and this has to equal to 0, basically the 0 vector. X, and then times, and then A minus lambda times the identity vector. So this becomes identity matrix, I'm sorry. So it becomes 1 minus lambda times 1, so 1 minus lambda, and then it becomes 10 minus a lambda times 0, so just 10. Then it becomes negative 3 minus lambda times 0, so negative 3, and then 12 minus lambda. Then we have this. And now basically this has to equal the 0 vector. However, since we want our vector to be non-zero, this means we only want to work with this matrix. And for this matrix to basically validate this equation, its determinant has to equal to 0. The determinant of a 2 by 2 matrix is just multiplying this entry by this entry and then subtracting this, so the diagonals. So it becomes 1 minus lambda times 12 minus lambda, which becomes lambda squared, and then minus 13 lambda, and then plus 12, and then minus 30, which is plus 30, is equal to 0. So this becomes lambda squared minus 13 lambda plus 42, which can be factored out as lambda minus 6 times lambda minus 7. So this gives us two eigenvalues. Lambda is equal to 6 and lambda is equal to 7. So how do we find the corresponding, I'm sorry, I'm going to change this, and lambda is equal to 7. So how are we going to find the corresponding eigenvectors? So basically, we have to just plug it back in. So let's say we go back to lambda is equal to 6. So we go back to our equation here. So basically, and I'm going to basically generalize the vector x because it's basically, since this is a 2 by 2 matrix, x has basically two entries. So we have x1 and then x2. And then this is being multiplied by this matrix. But since we have the value for lambda, we can just plug in. So 1 minus 6 is negative 5, and then negative 3, 10, and then 6. And this equals 0. And basically, we can multiply this out to create an equation. So we have negative 5x1. Actually, this has the order of multiplication has to change, actually, since this is a 2 by 1 and this is 2 by 2. So this should be actually, let me fix this. This should actually change here because there's also a rule about multiplying by matrices, in which I'm just going to explain in a second, where this should be actually negative 5, -3, 10, 6, and then multiply by the vector x, x1, x2. And the reason is because when we write out the dimension, so this is a 2 by 2 matrix, this is a 2 by 1, basically the number of column of the first matrix has to match with the number of rows of the second matrix for their product to exist. Now this creates an equation in which -5x1 plus 10x2 equals 0, this is a 0 vector, and -3x1 plus 6x2 also equals 0. Now this has infinitely many solutions, so we can create actually a parameter for it. So we can let x1 to be t, and therefore if we solve for x2, we can see that x2 is basically, so 10x2 is equal to 5t, and therefore x2 is t over 2. And this is basically a general solution for all the solution. If we plug it back in here, we see that -5t plus 5t is 0, -3t plus 6 times t over 2, that is also 0. So basically our vector x is the vector t and t over 2, but since we want the eigenvector, that is when factoring out the t, and this is our corresponding eigenvector. So the vector, or basically the vector 1 and 0.5. Now we go back to when the lambda is equal to 7. So for lambda equals 7, what do we have? So I want to choose blue. So we have, this becomes -6. So let's see, -6, -3, 10 and 5 times x1, x2 equal to 0 vector. And this becomes -6x1 plus 10x2 equals 0, -3x1 plus 5x2 equals 0. This again, similar to the last one, has infinitely many solutions, but we can create parameters for it. So we can let x1 to be t, and therefore solving for x2, we see that is in fact 3 over 5 times t. This is a general solution. We can check it. So -60 plus 10 times 3/5 is 60. That becomes 0. -3 times t, -3t plus 3t is 0. So the vector, the eigenvector becomes the vector 3 and 3/50, which is the same as basically factoring out the t and 1 and 3/5, and that is our eigenvector. Thanks for watching. I hope you enjoyed this video, and goodbye.